Hello again, let's get started. X to the half power, that is the square root of x. Now, guys, keep in mind that the fourth root of x squared, that is also the square root of x, or x to the half power. And remember, the fourth root of x squared, that's x to the 2 over 4. 2 is called the power, 4 is called the index. So that's x to the 2/4 power, but remember, 2/4 is a half, so x to the 2/4 power is x to the half power. And x to the half power is, in turn, square root of x. And in a similar fashion, in any situation where the index, let's say 6, is twice as big as the power, which is in this case 3, then you have the square root. So if you have the 6th root of x cubed, the 8th root of x to the 4th, the 10th root of x to the 5th power, and so on and so forth, you have incognito the square root of x. A similar thing works for the cube root of x, where the index is 3 times as big as the power, like 12 and 4, 15 and 5, 9 and 3, so on and so forth. So there's all that. Now let me scroll down. Now be careful. You can't just recall, radical x plus radical y will not simplify in general. You can't bring the plus y inside. You can't say the radical of x plus y. Now you can bring the timesing, the multiplication inside. Radical x times radical y is radical xy. Now guys, keep in mind, and I should have said a little bit about that up here, we're assuming the whole time, particularly for the half power or any even root, that x is positive. We're going to assume throughout this video that x is positive. I was assuming that the whole time here when I was doing this a minute ago. I was assuming that, and I'm going to assume that henceforth throughout this video and through many videos, or however many I do. But anyway, I'm assuming x is positive, or any variables, y, whether it's x or y or z, I'm assuming that variable is positive. I'm assuming all variables are positive. Okay, now radical x plus radical y won't simplify, but radical x times radical y is radical xy. Now, radical xy squared minus radical x squared y, remember, we can break this up. This first guy, radical xy squared, that's radical x times radical y squared. The second guy is radical x squared times radical y. But remember, guys, this is 2 divided by an understood 2 out here. The square root of y squared is just y himself, and assuming y is positive. And likewise, assuming x is positive, the square root of x squared is x himself. So radical y squared turns into y. And you could put the y right here to the right side. That makes it sometimes when you're typing, it makes it too easy to put the y inside the radical. You don't want to do that. The y is no longer inside. Once you do the square root of y squared and get y right here, y is outside. You could put the y right here, but out of aesthetic beauty, I put the y right here. It's okay if you want to put it on the right side, put it there, but just be sure you don't put it inside the radical. And in a similar fashion, I turn radical x squared into x. That's right here. And now, I can't mess with radical y right here, and in a similar vein, I can't mess with radical x right here. So I've got, this is y times radical x minus x times radical y. And there we are. But I can't go any further, and that's all I'm saying right here, okay? The square root of 5 squared is 5 itself. The square root of 7 squared is 7, and so on, okay? Now let's look at this. The square root of x to the 11, y to the 24. Now here's the thing. We don't really care what's x and what's y. We care about even and odd. Now x, we'd be happy if that was 10 or 12, but it's 11. And now y is good. 24 is even, but 11 is odd. And we're doing a square root, so we need evenness. So what I do is I break, and then I got minus this other guy. We'll worry about that other guy in a minute. We'll concern ourselves with him shortly. But for this guy right here, I break up x to the 11th as x to the 10 times x. And by commutativity, I put my x over here. You could put it right here if you wanted to by commutativity. I just chose to put it over here. So x to the 10, the y to the 24, and there's this other x, because I broke up x to the 11 as x to the 10 times x to the 1, okay? Now, for this other guy minus the other guy, this x to the 5th needs to be broken up as x to the 4th times x to the 1. And again, to get the 10 and the 4, I chose the biggest even integer that was smaller than my original number. Like 10 is the biggest even integer that is smaller than 11. And then 4 is the biggest even integer that is smaller than 5. So that's how I chose the 10 and the 4. Okay, now here's the thing. Now x to the 10, now what we can do is, remember by the law of exponents, we can take this 10 and divide it by an understood index of 2 right here. 10 divided by 2 is 5, so x to the 10 inside the square root comes out of the square root as x to the 5th. He's liberated. This y to the 24th, we half 24 and get 12, so y to the 24th comes out as 12. And then now this x to the 1, he can't come out, so he's just stuck in there. We won't even, our objective is to get integer powers, okay? Yeah, we could write this as x to the half power, but that'd be kind of silly. Our whole motive is to get integer powers. Now, x to the 4th, square root always halves the exponents. So that comes out as x squared right here. Y to the 30th comes out as y to the 15th. But now this, again, for the same reasons, x can't come out. So this x is stuck inside here, right here, where my cursor is. He can't come out. But now, if you're good there, let's move on. Now notice that this term minus this term, they both have a radical x in common. We can take out radical x, and that would just leave me with x to the 5th, y to the 12th, minus x squared, y to the 15th. So I just filtered out or factored out a radical x. And by radical, I always mean square root. So there's that. And again, all variables are positive, as always. Now, I want to do one more thing. You see these terms here? I want to factor out between x to the 5th and x squared. I pick my term with the smaller exponent, so x squared has an exponent of 2, whereas x to the 5th has an exponent of 5, so I want to take out x squared, the smaller of the term with the smaller exponent. And then between y to the 12th and y to the 15th, I take out y to the 12th because 12 is smaller than 15. So I take out x squared y to the 12th. Now the radical x, it's been multiplied by these two. Everybody's been multiplied. But anyway, multiplication is understood. So I got x squared times y to the 12th times the square root of x times. Now you're like, well, how did I get x cubed minus y cubed? Remember, I factored off x squared y to the 12th, so that's going to subtract 5 off of my x exponents, no pun intended, and that's going to subtract 12 off of my y exponents. So now, no, excuse me, it's going to subtract 2 off my x exponents, and it's going to subtract 12 off my y exponents. So it's going to subtract 2 off of my x exponents. It's going to subtract 12 off of my y exponents. So if I subtract 2 off of my x exponents and 12 off of my y exponents, x to the 5th turns into x cubed, y to the 12th disappears. There's nothing left. And now over here, I do the same thing for this term. X squared disappears. There's nothing left on account of x. Y to the 15th, now I subtract 12 off the y's, remember. So 15 minus 12 is 3. So I'm left with x to the 3 minus y to the 3. I subtracted 2 off this x exponent, the y disappeared. I subtracted 12 off the y exponent, and this x squared term disappeared. We took all that it had, If you have x squared and you subtract 2, that leaves you with x to the 0, but x to the 0 is just 1, and 1 times y to the 15 is itself y to the 15. Or 1 times y cubed is itself y cubed, as the case may be, okay? So I get x cubed minus y cubed. And then remember by previous videos, by difference of cubes, you can factor x cubed minus y cubed as x minus y times x squared plus xy plus y squared. And then just refer back to previous videos if you are a little rusty there. And then now, here's the thing. X squared times x to the half. Remember by the laws of exponents, we can add that 2 in that half. That's 2 and a half, which is 5 halves. So there's that 5 halves right there. And then, so we got x to the 5 halves, y to the 12th, and then times my other stuff that I had before. I just wanted to go ahead and combine these. And I want you to go through all these steps and do the same thing for this guy right here. Now, problems like these, they won't be on most of your tests in your college courses, but it's good to know how to do this stuff right here where my cursor is. It's good to be able to weave in and out. It's good to know what you're doing, and I wanted to do this problem for that purpose. Okay, and I want you to do this one right here for yourself. Okay, let me just look at this one real quick. I don't want this video to go on much longer, but just this particular video. I'd like to move on to the next video. But radical xy, and by radical I mean square root, so radical xy minus radical x radical y, that's 0 because radical xy and rad x rad y, they're the same thing. We're assuming all variables are positive. And that is assuming in the backdrop that all variables are positive, okay? So that's an important assumption. We're always assuming that in all these videos that I've done thus far, and for the next several videos anyway, we're going to be assuming that. So assuming all variables are positive, this is true right here, okay? Let's stop this video, and I'll move on to the next video. I'd like to break these up at least a little bit. Thanks, and we'll move on to the next video.